Hello everyone, my name is Nafisi. I'm a linguist and self-taught NLP engineer, and today I'm going to be designing a custom NLP pipeline for social media text data. A pipeline that will be able to turn anything as like comments or text or tweets that are as noisy as this into something more clean and structured as that. Stay tuned. First, let's take a closer look at this tweet. So, as you can see here, with Twitter and probably all social media, we always have this @ sign at someone. So we convert this @ into something like user or @user. Also here the R. So they use this abbreviation to save some space. So we're gonna convert this R into something more like R, normal R. Here, all caps. So casing. Cheap here. Also, we have here a URL code that we're gonna like parse. So URL parsing. What else? Hashtag, and also like camel casing. So we're gonna get rid of the hashtag completely and still keep the words. So some remove the hashtag completely, but sometimes the hashtag can convey like can have some semantic values. So I'm not gonna get rid of it, but rather like remove the hashtag sign and try to remove this camel case, or convert the camel case into something more normal, more separate, like templates by itself, then space, then website, then space, etc. Also some repeated letters or even words. So repetition, and also emojis. So we're not going to remove emojis because they convey semantic meanings. They mean a lot. So let's take this tweet as an example. I heart Python. So if we remove the emojis, what's gonna be like end up with? I Python. What is that? Is it like positive, negative, neutral? Does it even have a meaning? So to avoid this mistake, we're gonna convert some like most used emojis into like words. So demojizing. So we're gonna be demojizing emojis. And this is not all. So we're gonna start by doing this first, then we go from there. We keep like updating and making changes. So let's get started. First, let's get the data. I'm gonna use command line. I'm gonna use Twint library, and don't worry about this because I'm gonna link the data in the description below and also the documentation. Twint search. Let's search for the word coding. All tweets that have the word coding. We're gonna figure out what programming language is most mentioned using the term coding. Coding, let's say since 2017. Okay, then the month, let's just do 1/1/00/00. Okay, so let's set the limit to just 500 tweets, and the output, let's save it as YouTube coding, YouTube coding.csv and CSV. There you go. So let's give it some time. In the meantime, let's go to the Google Colab and create new notebook. New. Let's get rid of this. Okay. Let's use this for, let's say, pip installs. Pip installs here. Then let's use this for packages importation. Okay, pip installs packages importation. Let's use this cell for package loading. If I can type this correctly. Code. Then we're gonna use this cell for like testing. So let's call it our labo. Then coding. Cool. So the data is done. Okay, let's get our file. Package loading. Okay, so let's import pandas as pd. pd.read CSV file. Let me grab the file real quick. So we call it YouTube, right? Right here. Just drag and drop. Okay, cool. So YouTube underscore coding CSV. YouTube underscore coding.csv, and it's a tab separated value. Cool. Here is our data. Nice. Is the label. Okay, text. The code. Now let's have a look at our data. Head. Oh, sorry. Nice. Looking good. So let's get rid of all of these columns and keep just the tweet. Where is the tweet? Somewhere in there. So here is how we're gonna do it. So data dot columns. Okay, copy all of these. Copy. Then we do data dot drop. We're gonna do columns equals to this list, and we're gonna keep the tweet and the language. Okay, in place equals 2, so that the change stays as is. If you don't do this, it's gonna default to false, then all the columns gonna come back again. Data.head. Cool. So we got the tweet, we got the language. And since we didn't specify language in the while scraping the data, I believe there are gonna be some other languages too. Let's see, data.sort values. Let's sort it by language. By language, sending. I can type that correctly. Equals false. Okay, there you go. ZH, is this like Chinese? Okay. UND. TL. Look at the PT. Is this Portuguese? A pessoa que eventuou o livre coding ela já tem lugarzinho reservado no colo de capeta. I kind of, it looks familiar, it sounds familiar because I speak also Spanish, so not fluently though, but let's see. Okay, first let's translate all non-English data into English. So which means the first function that we're gonna do is actually let's remove this from here. Let's keep this testing and label, and here is our coding section. Coding section, or NLP coding section. Cool. So now let's define a function, call it to English. We're gonna pass in a data as a parameter. Okay. Luckily for us, there is like Google Trends, I believe. Google Trends Python. Let's see. So here is the pip install. Okay, let's run this. Cool, it's downloading now. What else? Import translator. Okay. So from Google Trends import translator. Cool. Looking good. We're gonna create an instance of the translator. Translator equals translator. So and we're gonna pass in data, so translator dot translate the data that we're gonna pass in, then return data. Cool. Now let's test it out. Give me this one. Copy. Okay, let's take it to our label and say text equals to our string, Chinese string, ni hai, and let's add to English and pass in our text. It's not defined. Okay. And what does it return? Is it like text? Ah, translation.text. Cool. So we need to return data.text. Something is wrong. Let me see. Stack Overflow. Help. Okay, so it's a problem related to the version of Google Trends. So we're gonna pip install this version. This is what coding looks like in real life. Sometimes you get stuck with something like unpredictable. Okay, let's give it a go. Restart to runtime. Are we done? Let's drop all the columns again. Okay, looking good. Alright. Now it should work. String object has not to view text. There you go. So, but it's not translated into English. Oh, I bet. So, data equals return data. Okay, I got it now. So give me data.text. So I forgot to put this under variable. Sorry for my accent. There you go. So let me see what he's saying. And she loves to complain, making herself like an outsider. You have to pair coding at every term. Okay, so you have some bad words here. Cool. Ask for leave today, okay. Cool, our function is working now. Let's apply it to the data. We're gonna create a new column named translation. I'm gonna keep both columns so that we can like compare the results. So translation equals to data tweet dot, we're gonna apply what to English function, and we don't need to pass in the parameter because here is the parameter. So that's the parameter that's gonna go inside this function, that's gonna give us a result in a new column named translation. Sorry, let's see. Oh, here we go. So let's do data.head. Sorry. .head. Cool. So here is the original tweet, the language that came in, and the translation. Let's copy this. Sort them by language. Nice. Let me see. Cool. Here's the English. I mean the Chinese translated into English. What is the Portuguese? Here is the Portuguese. In. What's this in? Mandornia, Tucan, Coding, Kalo, Timelinia, Mandon. I'm so sorry. I'm so sorry if I'm like mispronouncing this. But here is everything translated into English. Cool. Looking good. Now let's create our second function, which is like URL parsing. I do see some URL here. Okay. So second function, here we go. URL Alright, so this is the parser. Copy. Let's comment this out. Cool. Okay, URL parse. Cool. So data equals URL parse, and we're gonna pass in the data. But first, we need to segment the data into like segments or tokens. So we need to tokenize the data first, then pass in each token. If it equals a URL, then we're gonna pass it to the URL parser to parse it, then extract the domain from it. Let's code that. And first, let me use Spacia library as a tokenizer. So pip install Spacia. Okay, install Spacia, and then download this English Core Web small. I'm gonna download the large one just for maximum accuracy. Let's install Spacia first. Now let's download the library. Okay, while it's downloading, I'm gonna load it. So package loading. So I'm gonna come here and Spacia.load. I'm gonna load the English Core Web large, the one I just downloaded. English Core Web small. Okay, let's comment this out. Cool. Spacia is not defined. Import Spacia. Sorry. Import Spacia. Cool. Spacia.load English Core Web. Nice, looking good. So now, first we need to tokenize the data, then pass in each token to the parser to extract the domain from the URL code. Cool. So we're gonna say tokenized data equals to, I'm gonna use a list comprehension. So give me token.text for each token in NLP data. Nice. Now I'm gonna do data equals, okay, hold on, URL parse. What you gonna parse? The tokenized data. If tokenized data. So how we gonna get hold of the token that is in a format of a URL code. So if you wanna give it a go, pause the video and try to figure it out and comment your solution below. Cool, here is my solution. Token. If token starts with, so I'm gonna P else in tokenized data. Okay, so dot starts with. Cool. So here is my solution, and my line of code. This is what it says. So this is the library we just downloaded. So what this do, it parses or extracts domain from URL code. So what I'm saying is, give me the domain of this token that starts with this HTTP, which is a URL code. If it doesn't start with that, just give me the token. So, and also of course we need to join these tokens to bring them back into one string. Here return, let's stay consistent, and data equals parse data and return data. You can skip this line, just return parse data, but it's your preference. Now let's go to our labo and try this out. Moment of truth. Text 2 equals, give me any tweet that has URL code. Let me see. This one. What is our lab right here? It's right here. So your parser. What's our function's name? Function name URL parsing. Okay. Here. Parsing, we're gonna pass in text number 2. Okay, NLP is not defined. Okay. NLP equals what's going on here? Sequence item 10 expected string instance parse result found. Let me try to debug this. So we tokenize the data, we pass in if token starts with HTTP, else token for token in tokenized data. Do I have to add one here? There you go, but Okay, they meet too. Oh, okay. Okay, it worked. So what does this parser do? It returns like a tuple, I believe. So the scheme, the netlock, the path, and a lot of other elements. So what we need is the domain. So it's like pretty much the second element, which is like 0, 1. So that's why we need to add 1 here. So give me the second element if it starts with HTTP. If not, just give me the token. And here we join all the tokens into one string. So we bring the data into normal form. Cool. So here is the parser. Let's do the emojis, shall we? So define emoji to text. I'm gonna pass in data. Cool. So now we're gonna loop through each element of the text and see if it equals an emoji. It's gonna convert it into a text. Okay, let's do that. Let's see. Tokenize. So we need to tokenize the data again. Equals this comprehension token.text for token in NLP data. Luckily for us, there is a library named Demojize or Emojize emoji Python library. Yeah, emoji. Okay, pip install emoji. So what this library do? You can emojize, but it needs like the name of the emoji, or demojize. So we'll give it the emoji and give you back the name. So for example, for this it gives you like red heart, or here thumbs up, and couple of columns here. Okay, so let's install the package. Let's comment this out. Pip install emoji, and let's import emoji. Cool. Import emoji. Nice. Okay, in a pre-coding section. Okay, so token the data. So emoji.demojize. We're gonna do demojized equals emoji dot demojize data. Return data equals demojized. Sorry, demojized. Turn data. Let's take it to our labo and test it. Or let's grab a tweet with an emoji. Here is one. Copy. Text tree equals. emoji to text. I'm gonna pass in text3 and see what happens. There you go. Grinning, Quentin face with tears of joy. Okay, I kind of don't really like the results. I with heart Python. What I'm thinking is I'm gonna build my own dictionary where the key is the emoji I would like to change, and the value is the text that I want to have in my data. Like for the red heart, I'm just gonna put love. I love Python. What do you think? Comment in the section below if you have a better solution. The advantage of building your own dictionary is that you can customize it with every single use case. Let's do it. I'm gonna build my dictionary probably right above here. Code. Okay. Okay, so my dictionary equals this one, and the value, hold on, so it's a string. The value gonna be love. Give me the most used emojis on Twitter. Let's just try this out. So tokenize. So this is a dictionary. So what we're gonna do is look through every single token, and if it happens to be within our dictionary, we want the value, our own text. If not, just give me text. Okay, let's do it. What we gonna call it? Emoji or custom text equals so my dictionary, and you're gonna give me the value of that token, if token in my dictionary, else token for token in tokenized data. Let's comment this out and return customized data, customized text, customized or data equals customized text, and we're gonna join our data. Sorry. Let's see. Let's use the same sentence. I love Python. There you go. Oh, it's giving me the string. Easy to fix. That's why I like using dictionary. Let's start with it. And give me love. Don't forget the comma. There you go. I love Python. Space, space, single space, double space here. So we're gonna come back to this spacing later on. I love Python. So far, so good. Now, what if this string or tweet has an emoji that does not exist in our dictionary? For example, sparkle. It's gonna return sparkles, the emoji, right? Let's see. Okay, now we demojize. Now we demojize whatever is not in our dictionary. So let's remove this. It's gonna confuse me. So text customer to text. Okay, data. Okay, let's keep it tokenized. Data equals emoji demojize custom text. Demojizing equals emoji that demojize custom text. Then data equals join demojizing. All right, let's see. Let's move this. Okay, I love Python. Sparkle score. It's demojized, but we have a problem with spacing. What's going on? Can we include it here? Emoji. Or token in tokenized data and skip this step. Let's see if it's gonna work. And data equals join custom text. Cool. One line of code. So in one line of code we were able to fetch the value from the key in our dictionary and also demojize the other tokens that happen to be like an emoji in one line of code. Cool. So now we're gonna skip all of this. So this one worked. And we have double space here, we have colons, which means the next step should be, you guessed it, data cleaning. Let's define data cleaning. I'm going to take in data as a parameter. So let's start with at sign. We're going to replace at name with user, just user, or at user. You can modify it the way you want. Okay, and we're gonna use regular expressions. And here is my advice to you guys. If you are like into the NLP, regular expressions are one of the most powerful weapons. If you feel like you are still like struggling with them, just spend more time in practice and we're gonna love them because they are very powerful and very fast. Okay, let's import our package, import re for regular expression, and okay, so data equals re.sub for substitute, Then we're gonna pass in the pattern. The pattern is the @ followed by any alphanumeric character, which also includes the underscore plus the dash. So we're gonna substitute this pattern with what? With just string user, or you can do @user. You can customize it the way you want. Then you pass in the data. Let's test it out. Data cleaning and clean text for me. Oh, return data. Why it's not working? Okay, so let's do A to Z, A to Z, 0 to 9, underscore. So we're gonna substitute @ followed by any that include this pattern with user. There you go. Now it worked. But why this? Yeah, one or more. Yeah, I forgot the plus sign, which indicates one or more. There you go. We got it. So now this @ is replaced by user. Let's use another @ that includes more complex patterns, like this one. I'm gonna leave it here. User. Cool. So we got this. Next. So we're gonna remove underscores, hashes and underscores. Data e.sub hashes, or so this bar stands for or, any underscore or hash. We're gonna substitute with just empty string from the data. Or so this is to replace any like compounds or anything that looks like this. For example, bootcamp develops, or this hashtag, for example, is to this. It's like camel case, but it's not camel case. There you go. So it separates two words that are linked with the underscore or hash. Cool. Next, data equals e.sub. So we're gonna remove anything so other than so this equals other than, so other than A to Z. Just copy this and be careful with copy and paste. Other than A to Z, which is like alphabets, lowercase or uppercase, or numbers. So we're gonna keep these. Other than these, just remove. but I'm gonna include some exceptions. So I'm gonna add comma and full stop, and full stop I need to put backslash full stop to nullify its function as a regular expression, comma, full stop, what else, percentage sign. I'm gonna exclude the plus sign. Remember, we are like parsing the code in tweets, so there might be some tweets that mentions C++, so I'm not gonna get rid of plus, otherwise the credit is gonna go to the C programming language. I think that's all, and you can still like customize it. So we're gonna replace these with empty string, so which means that we remove them from data, of course. Okay, so we said percentage dot comma and the plus sign and sign. Okay, so we have some extra space, but we're gonna deal with it later on. Let's normalize the R. So we're gonna substitute the letter R, which is followed by space, backslash space, preceded by space. I'm gonna set this to optional. I'm gonna replace this with the full form R in the data. Let's see. So they are coding. They are coding. So I need to introduce space here and here. That's why it's a good idea to have like a testing section. There you go. They are coding. Let's try. They are coding. It also worked. Cool. Now the R is normalized. What else? So everybody knows that it's social media, so there is no rules or anything, so you can write whatever you want, however you want, to an extent, of course. So some people are like writing, expressing their joy or their sadness by repeating some certain letters or words. Let's actually clean that. So the way I'm gonna do it is like so. So the full stop is very powerful, which means any character. So any character, I'm gonna store it in \1. This is like storing the pattern in \1. It's like naming it \1, like storing it in a variable \1 and more. So if this \1 is repeated one or more times, we're gonna substitute that for \1 only. Or let's do it twice actually, because sometimes the word good, like O, is repeated twice. Oh, it's not like God. God from data. Okay, let's try this out. You can also add flag v.I, which means ignore case. So they both mean the same. Okay, let's test it out. They are coding, which is good. Okay, don't worry about this emojis, we already dealt with them, which is good. Oh, so this is a regular expression pattern. That's why I need to put this, not \1. If I didn't put the R here, it's gonna assume that I want to replace whatever the pattern I'm giving, replace it with \1. Okay, let's test it out. There you go. They are coding, which is good. That's why I said I need to put 2 \1, because if I put only 1, then it's gonna give me just 1 character, which is God. See? So let's play it safe and do \1. Okay, I think we're done. Oh, camel case. Okay, that's the trickiest one. Data, if I can type in correctly, SAP. Okay, I advise you to stop here and come up with any solution. It doesn't have to be regular expression, and get hold of the camel case, or just fix camel case. Just fix it and comment in the section below. Okay, so here's my solution to the pattern to find the camel case. Okay, let's go to our secret level. Let's write a pattern here. Camel case and website template. Okay, so what we're gonna use is what we call, so negative look behind is just this. Okay, let's use it and test it out. And here we are targeting the capital letter. Cool. Now the positive look ahead, this one, and we are targeting all caps. There you go. So here we get hold of the last letter before the capital letter, which is inside the camel case. Let's test it out. If you are like new to the regular expression, this is like the most among the trickiest one. So start with the easiest one, then go up. Okay, copy and paste. So that's the regular expression pattern. So let's substitute that. So with single space in our data. Cool. Let's try it out. Okay, data science. So here is a camel case. There you go. You see? So now they are separated by space. Cool. I think we're done. Okay, spaces. Let's get rid of all the extra spaces and any space or double space sub. So we're gonna do regular expression, backslash space, backslash space. We're gonna substitute that for just single space in our data. Okay, backslash space, let's do backslash space and more. I'm gonna substitute that for one single space. This is the data. Let's put some extra spaces here and here. There you go. Spacing is gone. So to fix this space, there is a Python method, lstrip. Hold on. Lstrip. Yep. Also may return a copy of string with leading character. Okay, lstrip. Okay, let's remove return data dot. Let me see. Just double check. Okay, yeah. Dot lstrip run that again. There you go. Nice and clean. Okay, what's next? I think I saw bad word somewhere in the data, so let's clean it. I'm gonna be using a library called better profanity. There you go. Let's pip install it. Exclamation mark. Unexpected indent. Okay. There you go. Import the package from better profanity. Looking good. Now let's load the package. Let's organize this. So profanity filter. Just in case we wanna come back and customize our patterns, our code, so it makes it clear for us. So profanity load censor words. Cool. Now censor text equals, okay, so data equals profanity of censor with data. Nice. Let's try it out. Text 4. There you go. Nice and clean. Why this was removed? Oh, because it's not alphanumeric character. Okay, let's come back. So here, either we're gonna exclude the apostrophe or normalize the apostrophe. We're gonna exclude it. There you go. We cannot normalize it because if we convert any apostrophe s into is, what about possessive adjective? Here. So we're gonna turn my father's car into my father is car. See what I mean? Alright. So let's just exclude it from the pattern. Run this again. Run this, run that. Nice. I'll strip dot no data dot strip. Cool. There you go, nice and clean. Now let's apply all of these functions that we have created into our data and see what happens. Data.head call tweet, language and translation. Okay, so now we're gonna do data translation equals to data translation dot apply. We're gonna apply, so after the translation we're gonna apply the parsing, URL parsing, and let's give it some time. Done. Cool, that was quick. Data.head just to give me the first 9 tweets and see. Here is the URL, so it's part. So the thing here with Twitter is that t.co, so Twitter uses the t.co domain as part of a service to protect users from harmful activities, to provide value to developer, blah 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 blah. So they kind of hide the domain. That's why it's not really appropriate in our case to extract the domain. So I'm just gonna go ahead and just remove the URL code completely. I'm just gonna use the regular expression data equals read.sub, substitute anything that starts with anything that is preceded by space, and start with HTTP, probably even the S, so HTTP followed any non-white space character. So we're gonna replace that with an empty string from our data, and we're gonna return data. Let me make sure. From text to 0 to, there you go. Yeah, so I get rid of it. So preceded by space that starts with HTTP, this capital S / capital S meaning a non-space character, and more, yeah, meaning any character that is not space. Cool. So I need to load the file again. So space is already loaded. Let's load. Okay, so we're gonna start all over again because this data is already like parsed. Cool. Let's apply this. Okay. Now give me the first 9 columns. Let me see. There you go. See? So there are two HTTPs here. First one, second one, and here there is none. Nice. So we got rid of that. Okay, let's apply the next function. Translation equals data. Sorry. Translation dot apply data cleaning, right? So English parsing, no emojis. Nice emoji to text. No, we don't need the parentheses. Now it's demojizing the data. Okay, data dot head. Give me the first line. No emojis. Boom. The at is not. Oh, okay. So demojizing connection. A phone that just need a phone and internet connection. We can also replace n with and. If it's preceded by space and followed by space, substitute that with and. AND. Oh, look at this. Just need a phone and internet connection. Happy. So this will really be like handy when it comes to sentiment analysis. It's way better than getting rid of the emoji, right? Cool. Now let's clean the data. Data translation equals data translation dot apply data cleaning. Okay, so the data is ready. Data dot head. Give me the first line. Okay, the data is clean now. Use. Are you interested? Did we put use or user? User. So this pattern includes the R in user. So how can we fix that? What makes me do this is to include the apostrophe R. I can do this. Apostrophe R, or the one that is preceded by space. I think that will do. Let's see, user. Let's do text one. Data cleaning. Let's give it text one as a parameter. There you go, user. So we're good. Okay, so we fixed the user. Okay, now emojis are converted. Cool. I should have added this instead of thumbs up. Yeah, let's add it to our dictionary, and we can give it like it as a value. Cool. What else? What about C sharp? Because the hashtag is considered a non-alphanumeric character. Okay, so we're gonna use this. We're gonna match the sharp that is not followed by C. So C sharp language hashtag coding. Copy. Sorry for the confusion. That's the life of a programmer and coder. Nothing is easy and nothing is hard. Okay, where is here? There you go. Now okay, this one, give me this, copy, text 4 equals this. Now clean text 4 for me, please. There you go. There you go. All the hashtags are gone. Now let me add C sharp here just to make sure. C sharp and C sharp. C sharp is there? Oh no, it's not there. Why this is removed and not this one? Ignore case. What is it? Flag v.I. Boom, here it is. C sharp, C sharp. There we go. Okay, the C sharp is fixed. So we're gonna give credit to C sharp. We're gonna make sure that no one takes C sharp's points. Okay. Okay. What else? I think that's will do. Yeah, so let's load the data again. And apply it. So columns, drop these columns, then translate to English, parse, remove emojis, clean the data, give me the first 10. There you go. If everything works fine, we're gonna move on to sentiment analysis with text blob. So sentiment analysis. First we need to pip install it. Okay. Pip install. Don't forget the exclamation mark. Python, download the corpora. Then how do we import the package? Oh. Let's comment this out, do this. Here you go. So you create an instance. Okay, give it the data dot sentiment, and it gives you the polarity, subjectivity. All we need is the polarity to get the sentiment, right? Cool. So the package is important. Let's have a look at our data. Nice, looking nice. So text plot, and we're gonna pass in data. Okay, so data equals text plot data, and give us data dot sentiment dot polarity. There you go. Data equals return data. Cool. Now let's get polarity of this in a sentence, in a text. Let's use text 3. Okay, so sentiment analysis. Analyze text 3 for me, please. It's not defined. Did we import the package? Yes. No. Yes. So we need to create an instance, right? I don't think we need to. Yeah, we don't need to. So it's 0.5. What does that mean? Okay, here. So polarity. So between -1 and 1. So if it's less than 0, that's negative. Equal to 0, that's neutral. More than 0, that's a positive. It's actually let's code this. So if data is equal to 0, return neutral. If data is less than 0, return negative. Else return neutral negative. So positive, that's the last option, right? So equal to 0 neutral, data is less than 0 negative, else positive. Let's see. Positive. Nice. There we go. Let's apply this to our data frame. So we're gonna create a new column. Easy. Sentiment equals to what? Equals to data. Translation dot apply sentiment analysis. Oh, that's fast. Data.head, give me the first line. There you go. Let's rearrange this. Tweet language tweet language sentiment and then translation. Nice. Okay, so this one is positive, this one is negative. Now that we finished doing sentiment analysis, let's visualize this, and I'm gonna be using word cloud. Oh yeah. Let's create another function, call it word cloud data. Let's get some documentation. There you go. I mean, we need to install pip install word cloud, pip install word cloud. Run it, and now come back here, copy, add this to importation packages. Also, don't forget to import stop words, all caps. Great. So text, the text gonna be our data that we're gonna pass in, right? Let's indent all of these. All right, our text. True. Cool. So we look good, right? Cool. Let's try it out. Let me add stop words. It should be somewhere here. Let me see. Stop words. Yeah, it's right here. Stop words equals the capital letter stop words that we just imported. Cool. Let's run it and test it out. So word cloud, let's give it text 4. Name NP is not defined. Sorry. But we imported NP, right? NumPy is NP. NP. We imported NumPy as NP. Let's try it again. There you go. Word cloud, ladies and gentlemen. Difference with storage. Let's apply it to our big data. Okay, because to apply it is tricky. Word cloud takes string, so we have to code our way to gather all of these tweets into one long string. How are we going to do that? All tweets equals to list comprehension tweet or tweet in data dot translation. So these are all tweets. Now we pass in the all tweet to the word cloud. Let's see. No, it's still segmented, so we need to join it. To join. Let's see. Word cloud and check all tweets. There you go. Okay, so here is the code for you guys. Take it, change it, study it, modify it, make it your own, and let's see. Code, Python, okay, Python, coding, which is obvious, that's how we got the data science, programming, coding, day, programming. Okay, so Python pops up, huh? Okay, so take it, make it yours, modify it, and don't worry about the files. I'm gonna link everything at the bottom in the description below. So I'm gonna share with you my LinkedIn, my GitHub, my Twitter accounts. Feel free to comment, to contact me, to email me. I believe that knowledge in general should be shared. So let's democratize knowledge. Thank you for watching.